Well, it's a milestone for NASA's Mars helicopter, completing its longest flight yet. This comes as we get one small step closer to life on Mars, with an instrument on Perseverance's rover successfully making oxygen from the red planet's carbon dioxide atmosphere. NASA engineers hope the breakthrough will help future Mars explorers live off the land. With more on this, CTV's science and technology specialist Dan Riskin joins us for another edition of This Week in Science. Dan, let's jump right into it. Why is this rather a huge deal for the future of space travel?
Well, I mean, if we look at that helicopter, apparently just yesterday it made its third flight. We don't have video yet of that third flight, but initially it just went up and then it went back down. Now we've got this thing flying up to about 5 meters up, which is about twice as high as it was before, and then going over 50 meters, taking pictures of the ground, then coming back to where it took off from and landing. And these are the kinds of things that you'd want a rover to be able to do. Want a helicopter to be able to do, so the rover could know where to drive. So it could be like a little buddy that goes ahead and has a look. Just amazing stuff. What's possible for this a flying machine? Because
I think we've lost Dan there.
It's really incredible because there's no air up there. It's like 1% the density of the air on Earth. And so the fact that those rotor blades can even get a grip on what fluid is around them really is remarkable. And it's just really cool technology.
So you had dumb this down for me. There's no oxygen on Mars, correct?
Yeah, that I don't know if I can dumb it down much more than that. But yeah, there's no chance we don't oxygen. Yeah, so there's no oxygen there, and people want to go there. Yeah. And if they go there, they're going to want to breathe, right? And
sure.
So one way you could do that is to bring tanks with you, but that's heavy. And plus, it's not just for breathing. It's also, if you want to leave Mars, you're going to need to take off with a rocket there, and you need oxygen for combustion. And so the amount of oxygen you would need to bring to Mars for a rocket launch is intense. It's like the weight of a space shuttle. Much better if you could make it there. Mars does have carbon dioxide, and so that's CO2. The O there is oxygen. So can you make CO2 into O2? That's what plants do on Earth. So they've sent a machine. It's about the size of a toaster. It's called MOXIE. It's on the Perseverance rover, and its job is to try to make a little bit of oxygen. There it is there. And it's not enough for there's no one there to breathe it yet, but this is just a proof of concept. So this thing fired up. It made about 5 grams of oxygen, which would be enough for you or me to breathe for about 10 minutes. And in the future, a much larger version of that could be set up on Mars, which is just pumping oxygen out all the time, converting the carbon dioxide to oxygen. And arguably, this is a bigger deal than the helicopter that's getting all the headlines.
Are you telling me that we are going to be able to terraform Mars and live there without the suits and everything?
Well, it's still pretty darn cold, and also the pressure is pretty low. So I think we still have suits, but in terms of like what we fill our little rooms with and what we fill our little spacesuits with, where does that oxygen come from? This is the step in the right direction. And you know, there's a neat parallel to the history of the Earth, because a lot of people think that the oxygen on Earth has been here all along, but it hasn't. Oxygen on Earth is made by things that photosynthesize. So if you go back like 3 billion years, there was only carbon dioxide here, too. There was no oxygen. And then life evolved the ability to photosynthesize, and algae formed. And the algae produced this waste product, which was oxygen. And at first, oxygen killed everything. It was called the Great Oxygenation Event, and it wiped out almost all the life on Earth because it's a poisonous gas. But over time, because there was so much of it around, other things evolved that could take advantage of it. And so we've evolved the ability to breathe this poisonous gas, and we need to take it with us to Mars if we want to live there. It's just really neat how things come full circle, and the connection between what's happening on Mars right now and what happened on Earth 2.4 billion years ago.
So you're saying our future on Mars is going to look more like Mars at the beginning of Total Recall than Mars at the end of Total Recall. I got it. Thank you very much, Dan Riskin.
Thanks a lot.
Hey, thanks for watching. If you liked this, be sure to subscribe here, or you can check out more Your Morning videos right here.